So now this example is where we basically set up a ratio to compare original versus modified. Okay? So this is something we did in our kinematics unit. And so I'll just kind of explain the theory behind why we're doing it again to you. So the attractive force between two masses is that many newtons. If the distance between the two masses is doubled, and one of the masses is doubled, what is the new force between the masses? So whenever you're given questions like this, where it's not actually values that you plug and chug into, you should write down original and then modified. So my original information is that I have Fg is equal to 3.7 times 10 to the negative 6 newtons. To represent mass 1, I have M1, M2, and R. When I represent this as a formula, I can say Fg is equal to G times M1 times M2 over R squared. So this is really equal to 3.70 times 10 to the negative 6 newtons. Okay? So, because if Fg is equal to this, and Fg is equal to this, I can conclude that this symbol representation is equal to that value in that numerical value. So now what I'm going to do is I'm going to set up a fraction to see how much has my modification changed by. What fraction could I use to compare? So I'm going to label Fg prime is equal to question mark. That's what I'm trying to figure out. What is the new force between the masses? Now M1 I'm going to say is 2. So 2M1. And then M2 I'm just going to leave by itself because it just said and doubled one of the masses. Then I have 2R. So my distance was also doubled. So now I'm going to write this out into another formula. So Fg prime is equal to G multiplied by 2M1, which is multiplied by M2, all divided by 2R squared. Okay? So now if I'm going to substitute in for my exponents. So I'm going to just simplify this one. So Fg prime, not Fg1, Fg prime is equal to G. I'm just going to leave this 2M1. Actually, what I'm going to do is I'm going to put this 2 out here and say G times M1 times M2. This top fraction means the same thing as this top fraction. I just put the 2 in a different spot. You can do that because you're just multiplying everything on the top. So basically it's like I'm kind of thinking about that I need to factor out my numbers. So if I factored out 2, I'm just going to put it there and say it's multiplied by the rest of this. Okay, now my exponents come into the brackets. So now I have 4R squared. Okay, now I'm really actually going to factor out my numbers here. So I'm going to say this is equal to 2 over 4, okay, so 2 over 4 multiplied by G times M1 times M2 over R squared. Okay, see that? I just basically factored out the numbers because I'm making a ratio to compare what is my modified compared to my original. Well, look, see here, this G times M1 times M2 divided by R squared, that's right here. So I can set this equal to Fg. And I can simplify this even more into 1/2. So Fg prime is equal to 1/2 times by Fg. Okay, so that's the simplification of how, from our original, what has really changed to get our modified. So Fg prime is now 1/2 times by 3.7 times 10 to the power of -6 newtons. So Fg prime is equal to 1.85 times 10 to the power of -6 newtons. So in your assignment you have I think you have 3 of these types of questions where you need to kind of work through and make a fraction, so factoring things out. The one thing you need to be careful about is this squared, is factoring or putting the exponent into the brackets so that you know what you're doing there. So now I'd like you to do your assignment.